Let us now discuss question number 11 and question number 12 from code 9 of subject physics from JEE Advanced 2015 paper 1. Let's discuss question number 11 first, and in this question we are given with a vernier caliper and we are given with a screw gauge, and then we have to find the least count of the screw gauge depending on the relationship which is given to us between vernier caliper and the screw gauge. Okay, so let us first consider the vernier caliper. For vernier caliper, it is given to us that main scale is divided into 8 equal divisions for 1 centimeter. So we can say that one main scale division is actually 1 by 8 centimeter. And now further it is given to us that 5 divisions or vernier scale coincides with 4 divisions of main scale. So we can say that 5 vernier scale divisions are equal to 4 main scale divisions. And as we know that least count of vernier caliper is given as 1 main scale division minus 1 vernier scale division. So using this relation here, we can put the value of vernier scale division here. It will give us 1 minus 4 divided by 5 main scale division, and which is equal to 1 by 5 main scale division. As we know that our main scale division is 1 by 8 centimeter, so this will be equal to 1 by 5 into 1 by 8, which is actually equal to 1 by 40 centimeter. So the least count of our vernier caliper we have calculated as 1 by 40 centimeter. Okay, now let's take the screw gauge, and in these first two options it is given to us that the pitch of the screw gauge is twice the least count of the vernier caliper. Okay, so for options A and B, our pitch will be 2 times the least count of the vernier caliper, which is 1 by 40 centimeter. So it will be 2 divided by 40, which is equal to 1 by 20 centimeter. Now there are 100 divisions on the circular scale of the screw gauge. So the least count of the screw gauge will be equal to pitch divided by 100. So that will 1 divided by 20 into 1 divided by 100 centimeter, and this is equal to 5 into 10 raised to power minus 4 centimeter, or as options given to us are in mm, so let's convert it into mm. It will give us 5 into 10 raised to power minus 3 mm, and if I write it in decimal form, it will be 0.005 mm, which is our option B. So our option B, from this calculation we have found that option B is the correct answer, and the option A is wrong. So now let us see what are the remaining options. For option C and D, it is given to us that the least count of the linear scale of the screw gauge is twice the least count of the vernier caliper. Okay, so we can say that least count of linear scale, it is equal to twice the least count of the vernier caliper. So our vernier caliper least count is 1 by 40, so it is 2 divided by 40, and again it will be 1 by 20 centimeter. So this is our least count, and as we know that one complete rotation of circular scale moves it by 2 divisions, so our pitch will be equal to 2 into 1 by 20, which is actually 1 by 10 centimeter. Now the least count of screw gauge is given by pitch divided by number of divisions on the circular scale which is 100. So our least count will be 1 by 10 multiplied by 1 by 100, that is equal to 10 raised to the power minus 3 centimeter. And if I convert it into mm, it will be 10 raised to the power minus 2 mm, and writing it in decimal form, it will be 0.01 mm. And this is our option number 3. So option 3 is correct and option D is wrong. So our correct answers will be option B and option C. Okay, now let's move to the next question. In next question, what we have done, that we have taken Planck's constant h, the speed of light c, the gravitational constant g as the fundamental units, and now we have to find that on which of these the length and mass will depend. So we can do this using the dimensional analysis, as we know that the dimensional formula for Planck's constant is given by m1 L2 t minus 1, and c is actually a velocity, so the velocity is actually L1 t minus 1, and then the gravitational constant, that is m minus 1 L3 and t will be equal to minus 2. So now using the principle of homogeneity, let's first calculate the unit of length, and then we will calculate the unit of m. So let's say that length is proportional to h, c and g with their powers as x, y, z. So using the principle of homogeneity, we can equate the dimensions on both sides. So it will give us L1 is equal to m1 L2 t minus 1 raised to power x. Then we have L1 t minus 1 raised to power y, and then for g we have m minus 1 L3 t minus 2 to the power of z. So now if we equate the powers of m on both sides, we will have x minus z, that is equal to 0, and if this implies that our x is equal to z. Okay, so now let's equate the powers of L on both sides. We will have 2x plus y plus 3z, that is equal to 1. Okay, so as we know that x is equal to z, from here we can say that y plus 5z is equal to 1. Okay, so now equate the powers of t on both the sides. We will have minus x minus y minus 2z equal to 0, and if I remove this minus from all the components, so we have this x plus y plus 2z is equal to 0, and now again putting the value of x as equal to z, we will have y plus 3z is equal to 0. So if I subtract, let's say this is equation 1, this is equation 2. If I subtract equation 2 from equation 1, then 1 minus 2, I will get 2z is equal to 1, and this gives me z is equal to half, and the same value will be for x because x is equal to z. Okay, so now using equation 2, I know that y is equal to minus 3z, so this is actually minus 3 by 2. So our relation will become length is directly proportional to, as I am getting by 2 in all, so let's take it in under root. And then for x we have half, so x is the power of h, so it will be h, and then we will have g divided by c cube. So this will be our relation, and from this relation we can see that L is directly proportional to under root of h, and L is directly proportional to root of g. So our C and D option are correct. Now let's see the dependency of M on H, C and G. So again, using the principle of homogeneity, we can say M1 is equal to M1 L2 T minus 1 raised to power X. Then we have L1 T minus 1 raised to power Y, and then we have G, whose dimensions are M minus 1 L3 T minus 2 to the power of Z. So now equating the terms of mass on both the sides, we will have x minus z, that is equal to 1, and then equating the powers of L, we will have 2x plus y plus 3z is equal to 0, and equating the terms of t, we will have minus x minus y minus 2z minus 2z is equal to 0, and if I take out this minus, so let's say this is our equation 3 and this is our equation 4, so I can do 3 minus 4, which will result to x plus z is equal to 0. So now let's say this is our equation 5 and this is our equation 6. Then by 5, adding 5 and 6, we will have 2x is equal to 1, which will give me x is equal to half. And as x plus z is equal to 0, I can say that the value of z will be minus half. Okay, and now putting the values of x and z in this equation, we will have half plus y minus 1 is equal to 0, which will result into y is equal to 1 by 2. So this will give me m as directly proportional to root of h is on the numerator, and then we have c, and in root we will have g. Okay, so if I see this equation and from option, I know that m is directly proportional to root of c, but the option B is wrong, as m is inversely proportional to root of g, and in option we are given that m is directly proportional to root of g. So our answer will be options A, C and D.